So, just a quick video of my assembled power supply system. I am quite excited because this is getting very close to being done. I'm still waiting for some components, but I'll go over what this is. So, inside of this is a PCB sitting right around there, and another PCB sitting right around, actually right here, which these two PCBs are responsible for, actually that's also one there, are responsible for being my power supply system in my 3D printer. Now over here I have an LRS 35024, you can actually read that there. Meanwhile power supply, which is a very low profile 30mm power supply. I really recommend this power supply, like it's really good. The fan is a periodic fan, it only runs when it gets above a certain temperature, and even when it runs, like that is the biggest difference I've noticed between my cheap China PSU that I used to use before it destroyed itself. When this fan runs, it's actually not an unpleasant fan sound. It's not whiny, it's not scratchy, it's not annoying, it's very wide spectrum noise. It's more of a whooshing sound than anything, so it's not annoying to listen to, which is very good. And apart from that, it's not all the time. If I'm running a heat bed, it does turn on all the time after a while. But I rarely use a heat bed, so yeah. Anyways, so the power comes in over here through a, that is in frame? Yeah, that is in frame. So the power comes in here through a normal, like, IEC C13, or is it C14? I don't remember, plug, and then goes in here down to this board. Now this board has the two outer pins here connected, like these are connected and these are connected. So mains power comes to these pins here, and then they go directly over to this, which is an RS15-5, I think, also a meanwhile power supply, 5V 3 amps. So this gets mains directly from the plug over here, and that's always on. Then that passes 5V over to this board here, which then has a 5V output here for powering my Raspberry Pi, which is running my printer. Then from the Raspberry Pi, there's a USB cable coming over, the one connected to my printer, goes in here and then out to the printer there, and then there's a MOSFET in between which allows me to turn off the power to the controller, which I also find pretty neat. Now, so that's what that board does. Now going back to this board, after having basically just taken the power and bridged it onto this, the power also goes in here through a relay and then into the middle two ones. And remember, this is mains power. So then from the middle two poles runs back up along here and into the 24V power supply, and that is controlled by by the relay over here, which is in turn controlled by a MOSFET, so I can control it from my electronics. Now the way I'm going to have this wired up is that this relay board is going to be controlled by the smoothie board, while the 5V control board over here, which basically turns on and off the smoothie board, is going to be controlled by the Raspberry Pi. The reason I decided to not control this from the Raspberry Pi is that there's some firmware features in the smoothie board where if a heater fails and goes into a runaway state, like say the MOSFET fails and it just keeps heating, the electronics will attempt to cut off power, but it needs to have control over that, and by giving it control to this board it can cut off 24V, which is my heater voltage. Which incidentally also cuts off 12V, which is my fan voltage, but oh well, you can't win everything, and it's better than heating up and melting everything. So yeah, and then all of these things are exposed, right? I also have a 12V buck regulator sitting up here, powered from the 24V. And all these things then end up over here on a Minifit Junior 8-pin PC, well basically a PCI Express 8-pin connector, right there. So, oh, and then it mounts on my universal slot mount, but this is for when I just had the PSU with a cover and wires coming out. so this doesn't fit anymore. You can see how it's bumping screws in the back here. So but yeah, for now it actually works pretty well, although it does sit a bit too high, so I have to put some feet under here so it doesn't sag too much. But other than that, I'm getting very close. The things I need currently are, let's see, what was that? Oh, the things I need currently is a P-channel MOSFET for this, because I am switching this high side, which basically means I'm turning off the 5-volt line, not the ground line. And the reason I'm doing that is because ground is connected all throughout the system, so I have to turn off the positive. And then I still need the N-channel MOSFET for this board to control the relay and the relay itself. And those are the things I currently need. Now I will have another video up, probably at the same time as this video, showing how this is assembled, and yeah, it's actually fairly easy to get to the parts inside. Basically, all of the parts, all of these PCBs are bolted. As you can see, this is the 5-volt power supply, this is the buck regulator, and that's the USB board, and these two are the relay board. So these are basically bolted to the bottom here, and then this, and a screw under here means I can take this plate off, which with all things connected to it, just gently flip it over because it has cables connected to that and in here. So gently flip it over and solder the components onto it and close it back down again. So yeah, now I just gotta order parts and look forward to receiving them. But thank you for watching, and bye.